All right, so I kind of want to start on the bell work with you guys, because this one's a little bit, like, you got to do some decoding to figure out what to do and where to go. So we've got this garden, and I've got a picture off to the side for us to look at. It measures 12 meters by 16 meters, and they're going to put a pedestrian pathway, a sidewalk, around it. I don't know why they decided to use the words pedestrian pathway. They're going to put a sidewalk all the way around this. That's going to increase the total area up to 285 square meters. We're trying to figure out how big the sidewalk is. So I want you to tell me about stuff in the real world. If you were at a park and they had a garden with a sidewalk around it, would that sidewalk, like, change widths as you walk around it? Not usually, not unless you're like at an amusement park or something, right? So that sidewalk is going to stay the same width all the way around this garden. Is every sidewalk you've ever walked on the same size? No. And we don't know how big this one is. So we're going to call it X, because I don't know what it is yet. We're going to figure that out, though. How do you find the area of things? Multiply. In a rectangle situation like this garden, what pieces would I multiply together? 12 and 16. 12 is like our width, right? And 16 is like our length. So if I wanted to find the area of this whole thing, I would multiply the length and the width together. Can you guys multiply 12 and 16 together for me? 192. So that'd be 192 meters squared, because they're measuring this in meters, right? All right. I know what the area of the whole thing is, because they tell me it's going to increase to be 285. And I know that means I would need to multiply the length and the width together. So I need, like, the new length that would include the sidewalk. I need to multiply that by the new width, again, that includes the sidewalk. And that would give me my total area. So let's figure out what the new length and the new width are. Let's do the length first. So that would be this side over here. I don't care which side you call the length and the width. It doesn't matter to me. This whole side right here, we need to figure out how big it is. Well, I know, oh, I put my mark in the wrong spot. I know how big it is from here to here, because that's the same as the garden. How big is the garden from this point to down here? 16. What I don't know is this right here. And in math, when I don't know something, what do we usually call it? A variable. In this case, what variable should we use? X. They have it printed on my picture for me. It's what I'm most familiar with. So I'm going to call this X. And then down here, we have the sidewalk again. How wide is that sidewalk again? The garden is 12 by 16. How big's the sidewalk? Is that something that we know right now? No. No. So since I don't know it, what should I use to represent it? X. So I want to take all the pieces here. I want that total length, so I want to put them all together. If we knew that X was 5, I'm just pretending for a minute. If I knew that X was 5, how big would that whole side be? 26. Tell me what you did to get 26. Yeah, if X was 5, it would be 5 plus 16 plus another 5. In this case, I don't know that x is 5, but I'm going to use those same skills to write this expression. How many x's are we adding together here? 2. And then I'm also adding in the 12. So I would call this 2x's, or 2x, plus, sorry, not 12, plus 16. My bad, I said the wrong thing. 2x plus 16 is that whole side right there. So that's my new length, 2x plus 16. I'm going to put it inside parentheses because we're going to multiply that to the new width. So now I'm looking across the top. I need to find a way to represent from right here all the way over to right here. Similar to the side over here, I know how big it is from right here to right here because that's the garden, right? How big is the garden right there? 12. And then we've got the sidewalk on either side, and we're using what to represent how big the sidewalk is? X. Because the sidewalk stays the same size all the way around this garden. So how would I represent that whole side then? If I put together the x and the 12 and the x. 2x plus 12. So I've got my new length, I've got my new width. Do we know what the total area is going to come out to be? Did they give me that information? 285. So I have that. Wanting to know the width of this sidewalk, the width of the pathway, we're using x to represent that, right? So if I solve this for x, I will be able to find the width of the pathway. Give me a synonym for solutions. Roots, x-intercepts. What form will give me the roots, the x-intercepts? Factored form is absolutely correct. Put in factored form. I'm going to have to get it equal to 0 before I can put it into factored form. Because right now, even though I have two factors, it's not factored form because it's not equal to 0. I would love it if it worked that easily. It doesn't. Unless that 285 gets subtracted from both sides and turns into a 0, I can't do that. So I'm going to have to use some double distribution. So let's do that first. I'm going to take 2x and distribute it to both of these pieces. What's 2x times 2x? 4x squared. What's 2x times 12? 24x. And then it's called double distribution because I still need to distribute what? The 16. So I do 16 times 2x, and I get, 32x. And then I do 16 times 12, which you guys did for me already over here, 192. Equals 285. Now that I've double distributed, I can subtract that 285 from both sides so that I get it set equal to 0. So I'm going to subtract 285 from both sides. And while I combine those, I'm also going to combine these two together. So I get 4x squared plus, what's 24 plus 32? 56. So I have 4x squared plus 56, 192 minus 285.
Negative 93.
Yeah, so it's going to be negative 93 because we're subtracting a bigger number. All right, I've got it equal to 0. And we said we need to put it into factored form so that we can get the x's alone, right? So what's my first step if I'm going to try to factor this? What do we always do first when we're trying to factor? I'm sorry, one more time? I still can't hear you, I apologize. If I add 93 to both sides, then I don't have it equal to 0 anymore. We're going to do the x thing, so the x and the area model, absolutely. So let me draw my area model here. Before I write any numbers in my area model or in my x, what do I need to do? Something I always need to do, but it's really easy to forget. Look for a GCF. Do we have a GCF? No. I really wish we had a GCF, because these numbers are kind of big and I'm a little intimidated by them. But it's not going to work. Okay, so now since I know I don't have a GCF, I can put some things in my area model. Which two pieces can I just recopy right in there? 4x squared and negative 93. My A and my C. And then I've got my x. We need to multiply the A and the C coefficients together. So that's 4 and negative 93. Negative 372. Oh, that's scary. And then down on the bottom, I have my B term, 56. I need two numbers that are going to multiply to 372, but add to 56. 372 is a huge number, isn't it? So I want to find a way of thinking about this that's not so intimidating. Do you guys remember when we were simplifying square roots and we broke it down under the square root? Let's try something similar to that here, because that'll help me find all the things that multiply to give me 372. And I've got a clue right at the beginning, because what two things did we multiply together to get that horrible number? 4 and negative 93. I'm going to ignore the negative part for right now. We'll worry about the signs later. So I know that if I start with 372, I can break that down to be 4 times 93, right? Are you guys okay with that so far? Can I break down 4 at all? 4 is what times what? 2 times 2. 93. Well, I know 2 won't go into 93. Will 3 go into it?
Yeah.
That would be 3 times what? 3 times 31. I know I can't break 2 down any further because it's prime. I know I can't break 3 down any further because it's prime. Can you guys think of anything that'll go into 31?
No.
I can't either. It's not even, so 2 doesn't go into it. 3 doesn't go into it, and I know that because 3 goes into 30. So if I make it 1 bigger, 3 won't go into it anymore. 5's not going to go into it. Does 7 go into it? No. What about 11? No. This is as far as I can take it. That's not quite as scary looking as I was expecting. That's only 4 numbers, right? If I multiply those 4 numbers together, what do I get? 372. If I group these numbers, like 2 times 2 to give me 4, 3 times 31 to give me 93, if I multiply those numbers together, I get 372. I can look at different ways of grouping these numbers together. Like, I could do it like this. What's 2 times 2 times 3? 12 times 31. Grab your calculators real quick and make sure that that actually multiplies to 372. It does, okay. Can I take 12 and 31 and get it to add up to 56? Hmm? 12 times 31. Does it multiply to 372? Cool. Can I get 12 plus 31 to add up to 56? Okay, so that grouping didn't work. Let's try a new grouping. Do you guys see two numbers that we could multiply together that we haven't tried already? What'd you say, Alex? 31 and 2. So if I multiply 31 and 2 together, what would that give me? 62, and then I have to use these other two. What's 2 times 3? Multiply those two together. Make sure that it gives me 372.
That's it.
When you multiply them?
If you put one of those as negative, it'll give you 56.
If I make one of them negative, it'll give me 56. Which one should I make negative?
6.
The 6 should be negative. My B term, is my B term positive or negative? Positive, so I know the bigger number has to be the positive one. So I would have 62 and negative 6. Can you guys double check real quick on your calculators that if I do 62 minus 6, do we get 56? That didn't take quite as long as I was afraid of. I thought this was going to take forever with a number like 372, but when I break it down like this, it's a little bit easier to find those numbers. Okay, so I'm going to have 62x inside my area model, and I'm going to have negative 6x inside my area model. We're going to look at just 2 squares at a time, and we're going to pull out the greatest common factors from these. I don't want to start with the biggest numbers because I'm a little bit afraid of those. So why don't we start with these two? 4x squared and negative 6x. 2x will go into both of those. I'm going to stay away from the 62 and the negative 93 for a minute because I'm afraid of those big numbers. In fact, I'd rather come down here and look. Negative 3. Are you sure 6 doesn't go into 93? Does it go in or no? No. Double check on your calculators always. 15.5, so that doesn't go in evenly. So we would have to go with the next smallest thing. You said it's 3? And I think when you said this, you said negative 3. How do you know whether it's negative or positive? Box that it's touching, that leading coefficient there is a negative. So I'm going to take a negative out with it. All right, let's move up, because now I think I'm feeling brave enough to at least look at the 4 and the 62. Does 4 go into 62?
No,
We get a decimal. So if I can't take a 4 out of each piece, what's the next biggest thing I could try? I can take a 2 out of each one? And would it just be a 2? 2x. All right, we've got one of our factors already. We're almost done with this. We just have the scary numbers left to look at. 31. Remember, when you're doing this, whatever you have right here, multiplied by whatever we're going to put right there, gives us this right here. So I can use that on some of the harder ones too, because 2 times what gives me 62 might be an easier question than what goes into 62 and 93. 31 goes into both of those. But 2 times 31 gives me 62. Would it be a positive or a negative 31? Positive 31. Look at that horrible thing that you guys just factored. We got 2x minus 3 times 2x plus 31 equals 0. What do I want to do with each of those factors now? Set them equal to 0. I'm going to move this up a little bit higher on my screen. There we go. So I'm going to have 2x minus 3 equals 0, and 2x plus 31 equals 0. For 2x minus 3 equals 0, what's the first thing I would do there to solve it? Plus 3 on both sides. So plus 3, I get 2x equals 3. Then we divide both sides by 2. A lot of times I like to leave things in fraction form, but what does x mean here? What did we say our x meant at the beginning? Yeah, the length of the pathway. When you're talking about lengths and widths and stuff, would you ever go to the hardware store and be like, I need a piece of rope that's 3/2 meters long? No. You would be telling them at the store, like, if you don't need a whole number of meters, you'd give them a decimal, right? 1.5. X equals 1.5, and we said this is the width of the sidewalk, and that's going to be in meters. Okay, so we got one of our answers. What do I do to the other one? Minus 31 on both sides. So I have 2x is equal to negative 31. And then just like before, I divide both sides by 2. Negative 31 divided by 2. Negative 15.5 meters. Do both of our answers make sense? Negative. And what are we talking about here? What is x? What is x representing in our problem? The width of the sidewalk. Can I have a width on a sidewalk that is negative 15 meters? No. We did the problem correctly, but in the context, this one doesn't make sense. Can't have negative sidewalk width. So that means it must be how wide? 1.5 meters. I need to take that answer there and put it on this grid. This is the first time we've ever had a decimal on my grid. So I'm going to need 3 places. Yep. Yep. So you need 1.5. It either needs to be all the way to the left or all the way to the right. Doesn't matter. So I fill in the first bubble with the 1, and then I fill in the bubble for my decimal point, and then I fill in the bubble for the 5. Awesome. Other than the fact that this was a very long and slightly beastly problem, do you guys have any questions for me? Yes, ma'am.
How do you type of problems go below the text?
Story problems are fair game. Something this long, complicated, with this many big numbers, that would not be fair for me to give you on the test when I'm also asking other questions. Good question. Alex, did you have a different question? Same question? Yeah. Story problems are fair game for the test. I'm not going to give you something this complicated on the test. Okay? This is a real application, though, because sometimes you're dealing with limitations as far as, like, how big can we make this? I know what I want the final size to be. And then they're like, okay, you figure it out from there. Just make it work. This would be a way to figure it out ahead of time before you start buying a lot of expensive materials. For the rest of class today, you have work time. You can work on any assignments that you have that are missing. You can ask me questions. You can start working on the review, which is on Canvas. Last time it was on paper, this time it's on Canvas. We'll go back and forth between these pieces. The reason that it's on Canvas this time is because I want you guys to get immediate feedback on whether or not you're understanding these things. Almost all the questions are automatically graded by Canvas. You have an unlimited number of attempts at the homework, or sorry, not at the homework, at the test review. I'm going to be looking for completion to score you, just like I did last time. So as long as you've answered each question at least once, you will get full credit for the review, okay? If that means you're struggling with just one problem, and so you do that one problem and you submit only one problem over and over until you get it right and you figure it out, that's okay. You don't have to do all the problems before you submit it. You can do a couple of them, turn it in to see if you got them right, and then do a couple more, turn it in to see if you got them right. As long as you have attempted all of the problems by Friday morning, you will get full credit on that review. You guys can work with a partner, you can work in small groups, or you can work independently, whatever works best for you. If you're sitting and playing on your phone, I'm more than happy to arrange for you to take your test early. Everybody has things they need to be working on here. I'm available for questions if you have them.